So I thought I'd take a lecture and just talk a little bit about some personal experiences that I've had with Ubicomp and the cloud over the time that I've been working in this space a little bit. It's a little bit of an unusual lecture. This is the kind of thing that would usually work a little bit better in person. It's more of a kind of stories, and so getting feedback from people and questions from people is really helpful when you tell stories like this. But I'm going to kind of pretend like I have people out there asking questions. And if you do actually have questions, leave them in the comments below, or we can talk about them in person if we ever see each other. So some thoughts on Ubicomp and the cloud. So the first thing that I would say is since that initial paper from Weiser came out in 1991, there have been a lot of people that have provided some critiques to the vision that he put forward. One of them, probably the first one that I was aware of anyway, was a paper by Bell and Durish called Yesterday's Tomorrows, Notes on Ubiquitous Computing's Dominant Vision. And they said a lot of really interesting things about the framing of ubiquitous computing that Weiser put forward. And some of the things that they pointed out is that there's this proximate future that's always talked about in ubiquitous computing, where it goes something like, in not too much time in the future, we're going to have this. Or in just a few years, we can expect technology to be like X, and therefore the world will be like Y. Often this suggests a very clean kind of future, a future in which we reinvent the way in which networking happens. We create a new internet or a new class of devices. We have a whole new way of interacting that's has a complete break and separation from previous ways of acting. And because so much of the literature, at least early literature in ubiquitous computing, was framed this way, it made it difficult to actually see the kinds of technological and research progress that were being made in the field, because people were always talking about the future as being this clean, homogeneous, fixed world. The rhetoric was very clean, but in practice, when you looked around at the actual technological deployments and kind of ways in which the world was changing, it was actually very messy. And so people were always framing their research in terms of what the future was going to be like and missing maybe what was happening on the ground because they weren't expecting to see that. They were expecting to see a completely different kind of world. So it's one of the critiques. There have been other kinds of critiques as well. For example, a paper by Yvonne Rogers that talked a little bit about the ways in which computing doing so much work for us would take away some of the ways in which we might like to live. It might be that the ways in which we seek to live a good life require us to do some of the kinds of work that computers could possibly do for us, but that we would just assume do because we get enjoyment out of it or because it offers us some sort of intangible reward that we don't want automated necessarily. So because of these things, if we aren't careful, we'll miss the progress or we'll push progress in the wrong direction. Another critique is that many places in the world have a very different experience of computing than what Weiser put forward. So Weiser's vision of computing looked very much like a suburban, Bay Area version of computing, where there's, they just talked generically about a sow, but the vision felt a lot like a suburban family with upper middle class, definitely sort of a white feel to it, where the coffee maker is firing up automatically and your car is very smart and you're very connected in a way that suggests quite a bit of resources and agency. And of course, lots of parts of the world don't have these kinds of resources, don't have this kind of agency, are more concerned about their privacy than they are about getting knowledge about, the traffic. And so because of that, one of the critiques has been that this is one version, ubiquitous computing is one version of the technological world that maybe doesn't serve everyone on the planet as well as we might like our general visions of the future to go. So a lot of critiques, good thoughts, and good things to reflect on about the ways in which we might envision different kinds of future as well. So my own experience, I've had the opportunity to work in several different startups in addition to my academic work. 4 of them are here. There have been 1 or 2 since then. None of them have been particularly successful. I certainly haven't made any money off of any of them. We've had a few customers in some cases. Spent a lot of time trying to raise venture capital. So one of the first one that I worked on was called Cube. I actually really liked this one. This was a service that was being implemented around the time at which Twitter and Foursquare and Facebook were all vying, along with several other companies, for attention in the space of not just social networking, but maybe the status update kind of world. And so Cube was trying to position itself as a kind of Twitter for context. It was a service that would enable you to easily tell people what you were doing, but not have to type in the text for it. And so not the kind of thing that we're familiar with Facebook now, where Facebook, you tell people what you're doing, like what you're eating or what you're thinking. Cube would actually tell you, I'm on the phone right now, or I'm commuting, or I'm in a meeting. That kind of thing. So the idea for, or where we imagine Cube would be used would be on a smart contact book, that before you would contact someone, you would see what they were doing so that you didn't interrupt them. The second thing I worked on was called Whisper.fm, and Whisper was a way to listen to podcasts over the voice channel. And so, again, this was a particular moment in time where it wasn't clear that data services were going to grow like they clearly have. And so we were imagining that for people that didn't pay for data, but they might like to listen to podcasts, we had a system set up where you could call in a number and listen to a podcast over the audio channel, because many people had unlimited phone calls, if not unlimited data. And there were some nice aspects of it, for example, using the touchpad to navigate. And if you hung up on the podcast and called back, it would pick up where you left off. So a lot of nice technology there. A third one was called Swear, and Swear was it was a gamification of social media sharing. And this was designed to come up with a bunch of different kind of advertisement-based gaming, where your ability to share various kinds of advertisement games and achievements with other people would get you rewards. So it was kind of like a loyalty points program for sharing media, games that had a prominent product placement, things like that. The last one was called Wait Scout, and Wait Scout was a system that we put together to try and identify using artificial intelligence what the current wait time was at restaurants. And this had some clever ideas about how to get that information along the way. And also the ability to connect to Yelp. So when you would look in Yelp or you would look in Open Table, you could see what the wait time was at each one of these restaurants in real time with some predictive work built into it. So these are all services that these are a few of the startups that I've leveraged. All of them has used cloud computing resources. All of them had kind of a ubiquitous computing sort of flavor to them. Cube used virtual machines. We used a service called SliceHost, which was purchased by Rackspace. We ran a bunch of virtual machines there. Whisper used a virtual machine as well, but we had to get a special connection from the telephone company that would route telephone calls to our cloud computer. So when people called a number, they would get connected to a computer, and on that computer we were running software that would play audio back to the person on the phone call. Swear was a web-based interface, so that was kind of easy. And then Wait Scout was the real interesting thing about Wait Scout there was the way in which we transformed the normal interfaces of Yelp to include our information, and we did that through various kinds of browser plugin technology. But we also used robocalling to call the restaurants to ask what the current wait time was in order to get our training data for our predictive analytics. We got remarkably good responses from the hosts working at restaurants who would pick up the phone and have a computer ask, hey, what's your current wait time right now? Please type it in minutes. And remarkable high compliance with people typing in how much the current wait time was. And we use that as the basis for predicting how busy people were. So all those had a lot of different interesting things happen. Sorry, I jumped ahead there. One lesson I learned is that robustness is really hard. So one thing that you try a lot, you put a lot of effort into if you're developing a cloud-based user experience is to make sure that you have high uptime. You never want your system to go down, because if your only way in which people use your system is by accessing it through a website, if your website goes down, you're losing money and you come across looking a little hokey because you can't keep your system up. Turns out that's really tough. We ran into a problem with Cube where we had redundancy built into our web servers so that at any given time multiple computers were available in order to answer our requests. But there was a point at which in one of our data centers there was maintenance being done on the backup generator. And so there was no electricity going into, the backup generator had maintenance on it, and the computers that we had redundancy on were both in the same data center. So we had two computers both in the same data center. One day there was maintenance being done on the generator, and while maintenance was being done on the backup generator that delivers electricity in the case of a disaster, an ambulance ran into the power pole outside of the data center and took down the power pole. So just at the moment at which the generator was being worked on, and so it was offline, there was a car crash and pulled the electricity down from the entire data center. And the whole data center went down, despite our redundancy within that data center, thinking that they had backup electricity. And just sort of this freak accident prevented us from being up. I think we were down for probably 8 hours at that time. And so since then, when the different cloud computing providers give you opportunities to place your resources in different locations across the country, I don't think that's so silly anymore. Putting one server in New Jersey and one server in Fremont, California, and one in Texas, suddenly that makes a lot of sense since I've had experience where freak accidents have taken down my data center. The big problem with that is that you have really bad problems with latency. Web consumers, I guess, web users that use services on the web have a really low tolerance for lag in websites. And it turns out that if your website, if you're operating in Southern California and your website is somewhere in the Northeast, there's enough lag because of the distance between those two locations that it can seem like your website is overloaded and it can provide a really bad user experience. So you have these two things working against you. You want redundancy, geographic redundancy, but you also want to make sure that your server is delivering content from a site that's closer to where your users practically are. So that's a hard thing to balance. We also wanted at one point to have redundancy across companies. So we wanted, to be able to say that if one company failed for some reason, we would have another company online to be able to deliver the same resources to our customers, basically the same website. And the latency between working with two different systems like this became, we weren't able to navigate it, and so we ended up not being able to get redundancy between multiple companies because it was just too bad of a user experience as a result because of the latency. There are some companies now that help to navigate this. I'm thinking of CloudFront in particular. There's a company that will help do content distribution. There are content distribution networks that help to reduce this latency. But that costs money, and as a startup, you're trying to save costs wherever you can. A lot of the work that we did when we were in these startups was working with venture capitalists or trying to pitch venture capitalists on what it was that we were trying to produce. And in particular, Cube is the one that I was most involved with talking to venture capitalists about. And it's just remarkably difficult to get an audience with a venture capitalist and then to convince them that what you are proposing is something that's interesting. I would say in particular I have a real technologist sort of bent. So my view on the world is very much someone who's like, this technology is fundamentally different, interesting, and enabling new worlds, different imagined worlds. And as much as that gets me really excited, that's not really the way venture capitalists work. The way venture capitalists work is primarily about how can this create new money? How can this create return on investment for me, whether or not it's a new technology or not? And so that was a hard thing for me to learn, that the people that, are often touted as being at the forefront of technology were not really looking for new technology apart from the way in which it enabled you to become really rich really fast. And so that was a difficult thing for me to navigate. Plus the culture's a little funny. I went in once to a venture capitalist up on, Sand Hill Road, I think, in the Bay Area, who will remain nameless, but, flew up there just for this meeting, had like a 30-minute slot with someone, who had the potential to invest millions of dollars in the company. Went in to have the meeting, and the venture capitalist was just obsessed with this feature on LinkedIn called Bump. I don't know if it exists anymore, but what it enabled you to do is to take two phones that were both running LinkedIn and bump them together to transfer contacts. And the way it would work is when the phones experienced a bumping event, they would both contact the server at the same time. The server would resolve the two phones that were in the same geographic location that had experienced a bump at the same time and do the transfer in the cloud as if the data had moved from one device to another. Well, it wasn't working, but, we didn't want to offend the venture capitalist, and the venture capitalist was obsessed with this idea, and so we spent 20 minutes of our 30-minute appointment trying to get LinkedIn Bump to work. At the end of the day, we didn't really get a very good chance to convince him, in this case, about the benefits of Cube. So that was frustrating, kind of par for the course. Since then, my partner at the time has gone on to successfully raise funding, and he's had to do 100 different meetings like that in order to get one person that's interested. The other thing that I thought was interesting is one of the questions that we would often get asked is, well, how do you envision you developing this company? And we were really interested in building a great company. We really wanted to see this service take off. We wanted to see it grow. We wanted to grow with it and improve the technology and grow a team and stuff like that. So we would say something like, our goal is to build a great company. And we would literally get laughed at when we would say things like that. And that was a little, I guess it was humiliating in a way, because it just showed like how out of step we were with the mindset of the people in the room who really were looking for an exit strategy, something like, sell this to Google or take down Microsoft or something like that. So dealing with venture capitalists can be really rough. That was a tough aspect of these services, but often required in order to get them to grow fast. In a couple of our companies, we tried specifically to take them to China because one of my partners had experience doing business in China and had been very successful in the past in China, but hadn't been doing things in the technology space. And so Cube was kind of like a microblog, kind of like Twitter, but the goal was different. We weren't trying to like communicate news per se. And we quickly ran into problems in China with the fact that all microblogging services are monitored and censored in China. And so when we proposed this service, we would immediately get pushback about how were we going to censor this material. And it was, very distasteful to suggest that everything that was going to be entered into our system was going to have to be run by a censor before it could be made public. And not only was that sort of just against our values in a lot of ways, the Chinese pseudo-government officials that were thinking about investing and allowing us to bring our service into China actually didn't believe that we would do it either. So they were very suspicious of a company that wasn't predominantly Chinese-owned. And so you couple that with the need to censor the stuff that's going through your system, this became very difficult to get a foot in the door, even though we did at one point have an office in China with our logo on the door and everything. Nonetheless, they quickly copied our product and attempted to bring it to market without a lot of success. So that was also annoying. And then a funny flip side is, as we were presenting this technology on the ground, we had someone suggest to us, hey, why don't, instead of doing this product, you do this other product? And basically they wanted us to develop a car logging mechanism that could be placed in cars so that the government could nominally track the traffic of all of the cars on the road. But of course, in addition to being able to monitor traffic on all the roads, it would also be able to track the movements of all the people in China as well, possibly without their being known. So that was a difficult environment. That required us to navigate a bunch of unexpected ethical, moral issues that largely we didn't entertain. We were just interested in getting our primary idea out the door. Didn't end up working very well. So a couple other things in the process of learning this. We realized that geographic domain and legislation hasn't really caught up with cloud abstractions yet. And you see some of this coming out in the discussions about maybe finances or discussion about security and the NSA monitoring communications. The idea that information, when it's in the cloud, doesn't necessarily reside within a geographic domain of a particular country. So when you store data in a data center, depending on the level of the level of cloud services you're using, you might not know which data center it's at. And if your data is being held in China versus your data being held in Ireland versus your data being held in the US, well, there are different kinds of protection about your privacy and expectations about what can be done with your data when it's in those different places, and also when it's traveling across borders. And it's just not the case that we have appropriate legal concepts set up yet to be able to navigate this world in which data is sort of stateless or borderless, but our laws are largely based on the integrity of sovereign states. In some cases, maybe alliances as well. We're working through this stuff. A lot of it is because of the revelations of Edward Snowden, and also because of the way in which money moves around globally, that some of the ways in which we deal with these regulations are starting to catch up. Another random thought is that although we talk about cloud computing as if it's very ephemeral and ethereal, at the end of the day, it's not. Cloud computing takes resources. And so these data centers are using enormous amounts of electricity. They're using enormous amounts of air conditioning. They have an enormous number of computers in them as well. And so it's easy when you are using a cloud service to forget that there's actual material, physical resources that are backing your service. And that can become convenient if you are someone that can afford that. And maybe if you are the victim of pollution for whatever reason, or you somehow have to suffer the effects of the externalities of someone else using a cloud resource because the cloud resource is near you, that can become, that can be a problem for sure. So it's important to just keep that in mind. That doesn't mean that we should stop doing cloud computing necessarily, because there are other ways in which it may be improving sustainability concerns, but it is a physical resource somewhere. Then lastly, just a random thought. The movie Avatar created 1 petabyte of data. That's an enormous amount of data, right? And that would not be possible without cloud resources. It's just not possible to imagine that a digital movie like Avatar could have existed without being able to leverage a company that allows your storage to grow kind of unlimited, right? Just one of the things that's enabled because of these cloud computing resources that you wouldn't at first imagine is dictated by digital resources like hard drive space. So anyway, last thing you might think about is if the 0th wave was theoretical computers and the 1st wave was mainframe computers and the 2nd wave was desktop computers and the 3rd wave was ubiquitous computing, what could you imagine might be the 4th wave? There's a lot of different speculation about this. Sometimes people will say wearable computers are the 4th wave. I think that's not really different than ubiquitous computing, to be honest. I think that's just another computer that you're owning and leveraging. I think the most compelling argument I've heard for a 4th wave has come from a couple different camps, but I'd say Gregory Abowd is one of them at Georgia Tech. And this is a vision in which human-computer interaction in the 4th wave stops drawing a separation between human and computer. And that human and computer start to become intertwined in ways that we don't really understand now or expect with our visions of like cyborgs that we thought in the past. And I would say that the idea of a wearable computer or a Fitbit is starting to push in this direction, the understanding that we're now computing and our physical bodies are becoming so closely intertwined that at some point they'll start to become intermeshed. We see this in specific medical devices. We see this with maybe pacemakers. Remarkably, hearing aids seem to be a very close connection that start to look like the 4th wave, where you can't really function without a hearing aid, at least with the same level as other people who have full hearing. But hearing aids also have the ability now to give you feedback through the audio channel as you're using them. And so not only are they giving you the ability to hear, but they're also processing the sound and giving you information through the hearing aid itself. Simple information now, but still a channel that would be surprising to leverage in some other way. So that seems to be maybe a direction that the 4th wave might be going. There's one other one that came to mind as I was thinking about the hearing aid. The Fitbit, the pacemaker, the hearing aid. Yeah, I mean, you could imagine digital contact lenses would be another example. Maybe RFIDs embedded in your body. People have been experimenting with that for a little while. The other one that I was thinking of was just recently the FDA has approved a digital pancreas. And what that is a device that people with diabetes wear on them that is connected to their bloodstream, that's continuously monitoring their blood glucose level. And if they notice it going in or out of the appropriate blood sugar bounds, will automatically dispense insulin into their bloodstream so that people with diabetes don't have to be pricking their finger continuously and then giving themselves insulin shots. So this just recently has been enabled so that someone with diabetes, can have this device that's digital, intimately connected to their body, and possibly even has an app. And so that's maybe starting to look like the 4th wave of computing in some way that, Star Trek didn't imagine that the digital pancreas was going to be what a cyborg was going to look like in the future. So that's just some thoughts about where we are as a society, some of my takes on computing, some of my experience with digital computing and ubiquitous computing in the cloud. So interested to hear your comments on that, any feedback that you have. Yeah, thanks for your attention.